Assalamualaikum. I'm going to explain today batch reactor experiment. Okay, this is the batch reactor experiment. Batch reactor, you know that batch reactor is used mainly for finding the kinetics of a reaction, or it is also used for a small scale industrial production. So as I said, it is mainly used for finding the kinetics. Here also our aim is to find the order of a reaction, and reaction is sodium hydroxide and it reacts with ethyl acetate to give you sodium acetate and ethanol. Okay, so right away I will come to the experiment, how we are going to do the experiment. So what we do, we prepare, suppose 0.05 molar NaOH and 0.05 molar ethyl acetate. Okay, and then we will mix it in the batch reactor. The volume will be double, so initial concentration will be half. Once you put it together, reaction will start, and we will measure the conductivity using the probe with time. We have software for that. Software will take conductivity measurement with time and will continue till like 5 minutes. So we have the data at a given temperature. So first experiment we do at room temperature, and we take all the data of conductivity versus time for 5 minutes suppose. Then again we repeat it and we heat the reactant, both of them, and we conduct at higher temperature, and we get the conductivity graph for other temperatures. So like this is at 20, so 25, 30, 35 and so on. Okay, so once you have the data, conductivity versus time, you have to process it. So I will just explain to you how to process this data. You know that how to convert conductivity to concentration. Using this equation, you can convert conductivity to equation. This is a measured conductivity with time. Lambda 0 and lambda infinity are initial and final conductivity. So once you know the concentration, you can plot concentration versus time graph, and if you can see A is a reactant, so it's decreasing with time, and makes sense. And you can see that the slope is initially it is higher because rate of reaction is higher, and slowly rate of reaction almost is 0 because all the reactants are being consumed. So now your job is to find the order of the reaction. So CAT graph is there. You look for different type of order, what equations you have. So if you search, you will find this is the equation for first order. ln Ca by C0 is minus kT. Try to fit this curve and see whether it is linear or not. Plot this versus time. If it's linear, then you can say, and look at the value of R square in Excel, you can say that this is first order, or not. Come to the second equation, which is this second order equation, 1 over Ca minus 1 over Ca naught equals kT. So you get something like this, is linear, and R square is close to 1, you can say that our equation is second order. Okay, and slope of the curve will give you the rate constant value, and in this way you can calculate the rate constant value at different temperature. You repeat same thing, you have the data for all, you have the conductivity versus time data for other temperatures, repeat the same thing, repeat the graph, get the slope value k, and you will get k values at different temperature, and then using Arrhenius equation you can find the activation energy for the reaction. Okay, that's it. I hope it's clear. Thank you. We are going to conduct experiment batch reactor as I explained to you. So we have reaction between sodium hydroxide and ethyl acetate. Okay, so I'm going to mix this in the reactor. This is your batch reactor. This capacity of batch reactor is less than 1 liter. So what we are going to do, we are going to mix 400 milliliter of sodium hydroxide and 400 milliliter of ethyl acetate. The concentration here is 0.05, 0.05. When we mix it, volume will be doubled, so your initial concentration will be half. of the 0.05. So you will be starting with the concentration Ca0, Cb0, 0.025 molar. Okay. So this is sodium hydroxide. I will add this first in the reactor. Okay, let me start the stirrer, and now you can see the conductivity value is rising, yeah, because this sodium hydroxide is conductive, so it has conductivity, and it will become constant now with this concentration. We are conducting this experiment at room temperature, so you can see the temperature is around 21. Okay. So this is stable now. This is the conductivity of 0.05 molar NaOH. Okay. Now, once we add this one, ethyl acetate, the volume will be doubled. Okay, and the conductivity will be half, because ethyl acetate doesn't have conductivity. So when we mix it, conductivity become half. It means mixing is complete. From there, reaction starts. So again, you will see that conductivity is decreasing because of reaction. So reaction between sodium hydroxide and ethyl acetate started. Sodium hydroxide is being consumed. You are getting sodium acetate, which is also conductive, but the conductivity of sodium acetate is much less than sodium hydroxide. So with reaction, you will see that conductivity will decrease with time. Okay. So I will add this ethyl acetate now. You can see the conductivity start decreasing because it is diluting sodium hydroxide, and after mixing it will be almost half of the previous value. So we started around, it will be 5. So you can see the data is already is being taken there in the software, and then we start the stirrer. After the half value of conductivity of previous value, you can say that this is the time t equals 0 where reaction started. Okay. So now we can see almost half of the previous value. Reaction started. Conductivity is decreasing with time. I can show you there in graph. You can see that the software is taking the data of conductivity versus time, and we can export this data to Excel. Export data to Excel, okay, and give the file name and so on. So you can see you will have data like this in Excel, and you can see the initial connectivity is high, and here we can say that almost is half of the previous value, connectivity value, as I said, and then you can assume that time t equals 0 where reaction started. So from here, take this value and assume is lambda 0, and then convert this data to concentration using value of lambda 0 and lambda infinity, which is constant at the given temperature, okay, and then process this data versus time, and so you will get the concentration versus time graph, and then later you can fit the first order equation or second order equation, and you can find which order fits better, and you can decide that okay, this is second order reaction, and then find the rate constant using slope and so on, and you will repeat the same for the data given to you at higher temperature. Okay, that's it. Thank you.